So next is the fault tree analysis as a tool for preliminary system safety assessment and system safety assessment. If you look at the definition that I've given on this slide, it's a deductive failure analysis, which focuses on one particular undesired event and provides a method for determining all the causes of this particular event. So it's very top-down oriented. You pick a particular top-level event and then you kind of start to come up with all the possible causes for this event using a tree-like structure. So you start this typically qualitatively by determining what failure modes can contribute to this top-level event. And then, of course, in the system safety assessment, you're going to add numbers to it. A couple of other things that I include at the bottom. I think the fault tree handbook by NASA, I think I've included on Blackboard. So an example is of a qualitative fault tree is given in this slide. Suppose we have a two display system, one for the pilot, one for the co-pilot, and both display systems show aircraft attitude information, and this attitude information comes from two gyros, which are the sources for the attitude information. And now suppose also that we have a standby attitude indicator. So typically on an aircraft you have the primary flight display over there, one over there, and then a standby attitude indicator somewhere in the middle. Okay, so what we're going to define, and this is always very important in a fault tree analysis, is a top-level event. In this case, it's a loss event. So the loss of all attitude information on the pilot instrument panel. Well, we'll break this down into two things. Of course, you can lose either all the ill attitude information that's provided on the EFIS, or all the information is provided on the standby indicator. In this case, you see I use a circle if I'm no longer going to add any more level of detail to the fault tree. I'm not going to split this anymore up. However, the block indicates I'm going to go down the tree a little bit longer. I'm going to split this particular event into multiple sub-events, sub-tree. In other words, there's another sub-tree following. So in this case, of course, I can actually mean that this happens when either the attitude source gets lost or the EFIS displays are lost. So in this case, it's an OR gate. If that happens, you lose EFIS attitude. If that happens, you lose EFIS attitude as well. This in contrast to this AND gate, which says that both these things need to happen. So if you look at the loss of all EFIS displays, it really means that you need to lose both of them, the pilot's ones and the one for the first officer, the co-pilot. Again, at this point you see we have reached a level of detail and we don't want to break it down any further. So this is an important decision you need to make in a fault tree. It's how much detail you're going to put in here. Because you can imagine you could potentially go even further into the causes of the actual specific EFIS breaking down. So when it regards to attitude source, it means that again you can lose the attitude source of the pilot, lost attitude source of the co-pilot, and I broke this down into either you're losing the gyro or you lose the symbol generator for both the pilot side and co-pilot side. Of course, this is just an example, but what you see is you see a nice mix. You see I came up with a top-level event and I broke it down on a set of basic events that could cause this top level from happening, and the relationships are established by a set of these logic gates, in this case the AND and OR gate. While qualitative means that I'm actually not including probabilities of failure to this fault tree. So I'm telling you this is loss of standby attitude indicator, but I do not include the probability that this loss happens. That's what I call a quantitative fault tree, and we'll talk about that in a little bit later. So what you see in the next two slides are some of the symbologies. Of course, we've already identified the basic event and the intermediate event. There are some transfer points if you want to go to the next page, for example, or an undeveloped event where you say, okay, I still need to do a little bit more work there to further develop my fault tree because I don't have enough information at this point. Now, in terms of the symbologies on the top, you have an AND gate, OR gate. There's also a thing called the majority vote, which tells me, okay, that the output event occurs if M of the input events occur. Exclusive OR, and then this priority end. And the priority end really means that the output event occurs if all input events occur in a sequential order from left to right. Well, I added another little example there. Suppose I have this particular fault tree. I have some top level event called Q, and this Q may happen if A happens, and B happens, and if A happens before B.